Assalamualaikum, my name is Muhammad Muhammad Tarmizi and this is my partner Muhammad Fibianullah. Today we want to present about our project, which is IoT humidity and temperature outdoor sensor via THINGSPEAK, MIT app and LCD display using ARDUINO Mega 2560 and ESP8266. Okay, this is our hardware we use in our project. So the first is DHT11. It used as a sensor to get the value of temperature and humidity from the surrounding. So this is ESP8266 01, which is we use to send the data to internet. We use a THINGSPEAK channel to display the data. And this is our RTC real-time clock DS1302. We use to save and get the current time data. And this is LCD keypad shield. We use to display the current date, time and day, humidity and temperature, and our predict weather. And this is Arduino Mega. We use as the main microcontroller for this project. And this is our circuit diagram for this project. So you can see here the connection, all the connection. So this is DHT11. It uses 5 voltage as an operating voltage, and the maximum current is 2.5 milliampere. So it can measure the temperature with a range is 0 to 50 degrees Celsius, and the humidity range, it can measure the humidity about the minimum is 20 and the maximum is 95%. So the tolerance for the temperature is plus minus 2 degrees Celsius, and for the humidity the tolerance is about 5%. So in DHT11 it consists of two sensors, which is humidity sensor and NTC temperature sensor. It also has an IC on the back of the sensor. So for humidity sensor, it uses the humidity sensing component, which has two electrodes with moisture holding substrate between them. So when the humidity change, it also change the conductivity or resistance of moisture holding substrate also change. So this change of resistance is measured and processed by IC. So for the NTC temperature sensor, it made by sintering of semiconductive material. So it works as a variable resistor, as like a rheostat with change of temperature. So they increase the temperature, so the resistor will decrease. And this is RTC DS1302 real-time clock. Its input is 5 volt. Used in our project to save the value of the time, date and the date. So basically RTC DS1302, it has a 31 bytes of static RAM, which is used to store the data. And this is ESP8266 01. We use to send the data to THINGSPEAK after we get the value from the DHT11 humidity and temperature. It uses 3.3 volt as the input, and it uses only 4 pins to make it a standalone device. So standalone means if we turn off the power supply, the coding or the source code still remain safe in this hardware. This is LCD keypad shield. We use to display the temperature, the humidity and the current time. You can see this, and the date and the day, and this is our predict weather. So this is our weather indicator. So basically we have two, which is cool and sunny day. So as a sunny day, we use a red LED as indicator, and for the green LED is for the cold weather. So in Malaysia, if it's rain, the temperature is low than 26 and the humidity is greater than 80%. So we add the function to this button on the keypad shield. As you can see here, first we have the select. So the select is used as to help the user know what is a command from the button. As you can see here, so it show the what is button to the function of the each of the button. Left is used to convert the Celsius to Fahrenheit, and the right is to Fahrenheit to the Celsius. And up and down, we used to swipe this row to this row. See, we use this, and the function of reset is to reset the system. Okay, now this is coding for the Arduino Mega and the SD display. Okay, the first is this is for call SD display library, and this is for call DS1302 library, and this is for call DHT library. And set the DHT data output pin in DHT type, set CLK data and reset pin. This is for set RS, E, D1, D2, D3 and D4 pin. Okay, byte is for sunny character, the second is for right dot, and the third is for left dot, and fourth is a cloud character, and the fifth for degree symbol, 6 is for C symbol, and the last one is a pole symbol. And this is our voice setup. As you can see here, this is for set the clock to the run mode and disable the write protection. And this is LCD display we use to set the column and row 16 and 2. So this is for initialize 1 as a sunny character, initialize 2 as left dot, initialize 3 as right dot, initialize 4 as cloud character, initialize 5 as a degree symbol, initialize 6 as C symbol, and initialize 7 as pole symbol. This is our current day set time, and this is for our current time set, and this is our current date set. So when we upload the coding, we set the time and date. So we put this symbol, so the data is stored to DS1302 and not on the Arduino Mega 2560. And then so the right button for Celsius reading, and this is a left button, and for Fahrenheit reading, and this is when you push up button to invert the row on the display, and this is a for down button to invert the row on display too. And this is for the select button used to display the command to user. For IoT as humidity reading, set the IoT as temperature reading, set IoT as Fahrenheit reading. And this one is for the set condition to predict the rainy weather. So when the rainy weather is this is for column and row. So this is for to display the cloud character. So this high, low, low and low is for LED green turn on while LED red is off. So else when the sunny weather, so this is for column and row. So this line for display sunny character, this line for column and row, this line for display the left dot, and this line for column and row, this line for display right dot. So this is height, low, 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 53 height. So this is for the LED red turn on while LED green is off. So this line is for delay for 9.5 seconds. That's all for the coding to on Arduino Mega 2560 and LCD display. And this is our coding only for ESP8266 because it had to separate. We have to separate the coding, one for ESP8266 and one for Arduino Mega. Okay, this is our coding. So this is hashtag declare DHT.h. This is for called the DHT11 library, and this is for called the ESP8266 library, and this is our channel THINGSPEAK API key, and this is for our Wi-Fi name we use, and this is the password. So this is the THINGSPEAK URL, and this what pin we connect to this DHT11 output pin. So we set the data pin and the type of DHT. This for initialize the client library. So for the void setup, it only has a Wi-Fi begin SSID / password. These are for initialize the Wi-Fi library network setting and provide the current status. So this is our void loop. Float hash equal to this the read humidity. Float hash replaced with humidity reading, and for this line is float t replaced with temperature reading. This is for the in the if loop. As you can see here, this is if Wi-Fi is connect. So we declare the post str and declare same as API key. So this line send the string to field 1 on THINGSPEAK. So the data is humidity. So for this line send the string to the field 2 on THINGSPEAK. So the data is temperature. These are for a new tab and so on. So for this line client is stop, and this is our delay to 20,000 because it's same as 20 second because THINGSPEAK needs a minimum 50-second delay between the updates. Okay, now is our project demonstration. Okay, our current time is 9:58 AM. Current temperature is 28 degrees Celsius, and the humidity is 76%. Today is Sunday, 23 April 2017, and our predict weather is about sunny. As you can see here, our predict weather is sunny, so the red light is will turn on. This is ESP826601. This is DHT11. This is RTC DS1302. As you can see here, current time and the current date is same to the on LCD display. It's about the same. So let's see on the THINGSPEAK channel. Okay, so you can see here on the THINGSPEAK channel, this is our channel 255359, and as you can see here, this is for a temperature graph, and this is for humidity graph. So when the data is collect, so the ESP826601 their function is to send the data to the internet to our THINGSPEAK channel. As you can see here, the current updated data is 10:01. As you can the date Sunday, April 23, 2017. So the same as this year. The current time and the date is same, and you can see here the current date and the current time, so all the same. So the data is about the real time, so we get the data and we send to the channel, THINGSPEAK channel. So you can see the difference of the weather, temperature and humidity. So yeah, you can make a graph to add the analysis. So this is which is a good. Okay, now we want to show how to use our MIT apps. So as you can see here, this is our apps, humid temp apps, and this icon are for to show we want to view the humidity and temperature. So let's get started. Okay, this is our main page. main page on the apps. That's the display of our name and our function. So let's get started. So this apps is used to to go to the web viewer. So there's the URL. You can get the temperature and humidity value from your apps or your Android. So this is pretty easy to use because you just press the start instead of you to go to the Google and search for the channels. It's good because MIT apps this app is reduce your time to go the web page. That's all from us. Thank you for watching. Please click the link in this video for more information. Thank you.